Yes, okay, so we're live. Okay, so welcome to my presentation. I don't know what it has to do with frameworks, but anyway, it's about building the design of a flexible INI library in LabVIEW. I'll start with an introduction and then I do some breakdowns of parts of the INI library. And some stuff about inheritance and what you can do with it, because that's the whole point of building an INI library with OO, that you can apply inheritance. If you have any questions during the sessions, please just raise your hand. I have no idea if you're going to make it anyway, because I have a lot of sheets, but please feel free to ask and interrupt. So my name is Wiebe Walstra. Also known on the forum as Wiebe at Caria. Also known as Wiebe, Wiebe. English people seem to have a big problem pronouncing my name. I'll listen to Wiebe. If you want to pronounce it correctly, you say Wiebe. So that's yes. Everybody got it? So we live or we work in the Netherlands. That's over here in a small city called Delft. It's about 800 kilometers in the old continent. That's 5,000 miles from Austin. So any problems I can just blame on the jet lag, right? Everybody knows how. Actually, this is not too much about INI files. It's more about what you can do with object-oriented and how I built the library with object-oriented tools, and how you can apply inheritance to make a library that is more potent. There are other tools like JSON, XML that might be better. Just pick whatever you want and use the tools to use those file structures. A little introduction about INI files. I think everybody should be familiar with it, but just for completeness. INI file is made up of sections. They have names. Each section name is usually unique. If it's not unique, it's the same section, if that's allowed. You have key names and key values. So you have key value pairs in sections. So that also means the names in sections doesn't need to be unique. So we have a name here and a name here. So they can have different values. We have some options for command, and then we have empty lines and things that are unknown. And once you start making a library for this, you'll find out there's also some fluff, spaces, white spaces, that usually needs to be ignored. But if you store it in memory and you save it, you still need to deal with it. INI file is not a standard, so you will never nowhere on the internet you will find a PDF or a specification about how this standard is. There's a wiki page, and Microsoft has some documentation on their implementation. But there are differences in implementation. In this presentation, I call everything inside a section the content of the section. And this is the place where NI stores their configuration file library. Is this palette tab in the file palette, and there you will find these files, and there's really not too much you can do with the NI files for INI files. You can open it and close it, and then you can read keys, write keys. These are polymorphic, so they work for all data types, or all base data types, pass strings, integers, doubles. And then you have functions to get the key names, get the key section names, the section names. And there are VIs to delete keys and delete sections. So here's how you typically use it. You open the file over here, and from there on the file is read in memory. So everything you do will not be dealing with the file, with the physical file on disk, but will be in memory until you close the file, and then it will be stored optionally to the file. So this one reads the key and you get the value, and this one writes the key, so it will end up in the E file. Typically you have a few ways to use them in a project. Either you open the file at the beginning of your program when it starts, and you start using and reading and writing keys, and then when you're done you close it when your application closes. Or you can open the file, get the data and close it, and then modify the data, and when you're done you open the file again, change the data and save it. It's not too fancy, I'll go over this very fast, get to the fun stuff. So in my application I have a lot of dialogues like this, and this is just one of many. All these tabs have options, and they all need to end up in the E file. Some tabs can be really complex. Over here I have an index in an array, and depending on the selected item I'll show the values belonging to that item over there. So in my application I have about 400 keys in 25 sections, so it can get large. Also, my client tends to evolve the project, and that's where we use agile development. And we have been doing that for 3 years. So as the project evolves, the ini file tends to change a little bit. So that also means I have to sometimes go from situations like this, where you have measurement 1 with key values and measurement 2 with key values, and you want to change it to an array of key values in a section. This is, I could have left this out, but this might give an impression on the complications of the project that I'm working in. In my application, you don't have to understand it, but it's just to maybe give a little bit idea of the complexity. In my applications, I have application values stored in the ini file, and then I have dynamic files, so I can open and close these, and I can open and close multiple of them at the same time. And it's all ini file based, except that in the scan file they are compressed in a part of the binary file. And in the application, in the windows that I showed earlier, all the defaults and the limits and the increment and scope, etc., whether control and indicator is enabled or disabled, it's all hard-coded. At least that was at the beginning, until the customer said, okay, I want application settings, and depending on the user settings and the application settings, I want controls to be enabled or disabled. I want the increment to be specified in the application settings, and I want each key value to be read either from the application values or the project or scan file, depending on the value in the application settings. Right, so that's just to indicate that it gets complex. And when they said I had to make this, I decided I'm not going to use the NIVIs anymore. I am going to replace the NIVIs, and when I have replaced them, I'm going to make a child to handle the complexity. Some stuff is missing from the NI library. There's no way to extend it. So all these VIs, they live in a library, and this library is in the VI lab. And all the VIs inside the library except these VIs are private. So if you want to make, for instance, a read key, you can't really do that, because all the VIs that read key uses are private. Right? So you cannot even make sub-VIs the way NI does. The only way actually is to copy the library. There's also functionality missing or bugs in the functionality. And if you want to change it, there's no way to do that, right? There's no inheritance, so you cannot override functions. The only way to is to copy the code, and then you get other problems because in newer versions bugs might be fixed, and you don't get the bug fixes because you made a copy. Definitely, for me, not the way I want to develop. So we have the open close and the read write and the get section and key names and the delete section or key. What I really want is a way to open files from a string, so I can just put a constant on my block diagram with the ini file and use that one. I want to native support for control references and variants. When I do anything basically with the VIs, I want to use regular expressions, and also delete key section, I want to use regular expressions. I want a ability to merge, extend, or override some functionality, and I want the option to use to work by wire or by reference. So more on that later. And there's a nasty bug with floating point, but I think anybody who worked with the NIWeek knows that, but I'll point it out later on. So, to make a library that handles all this, all the requirements that I have, I started breaking down a low-level API, and this makes sense, right? You have a configuration object, and it has a child that's a section. Everybody is a little bit familiar with OO, I hope? Or is this, yeah? Maybe, if not, then you'll learn something. But so a section is a type of configuration object, and it contains content, and the content can be a key, empty, comment, or an unknown object. So basically, this breaks down the ini file by line, and each line is an object, and there's a hierarchy where the content is in the sections. This turned out to be very slow, because the section has an array of content, and if you want to loop over all the keys, for instance, to see if a key name matches, it has to step into each object and check the name, or let the object check its name, and it's going to be very slow. Actually, I tried, and it is very slow. Too slow to be practical, usable. So the alternative that I had was to make sections. Notice the multiple, a class that contains all the sections, and then each section in there would have content. And the content is also plural, it has multiple lines, all the content of the section. And I decided to go with that. It should do this, it should be able to loop over all the sections. If there is a match, return some info, or delete it, or modify it, and optionally step into the content. And if it's not there, maybe add it. That's all it needs to do. So you can simply add all these functions to the class. So the data will also be very simple. It's just a 2D array, what do you say, array? And an array with children to hold the content. And then you can store the pre and the post, the name and the post, and all the items in the other dimension. So accessing the data can be done like this. Yeah?
What does pre, name, and post mean?
Okay, yeah. It's not very smart of me, but I think it's in a later slide. But pre will be the fluff that's before the name. So maybe spaces and a bracelet,
okay,
and other spaces. And then you get a name, and then in the post you get the closing bracelet.
So these are strings that make up what's actually written in the file?
Yeah, exactly.
Thank you.
So I'm not sure if everybody heard that, but pre-name and post makes up the section name and the bracelets in the file for all the sections. This is a bit overkill. The emplacement structure and the for loop can be removed, but this works as well. But if Steven was here, he would say that's not, let the compiler figure it out. But it's very simple. You get the data and you get the elements you want from the index, and then you get the data, and you can basically get the name or the pre and the name and the post, everything you want from the data. You can also access the children like this, basically an array, and you get the index from the array. And using that data, you can make these VIs to get it.
Question real quick. Can you go back to the previous slide? So the index for the child object, how did you get the right index for the child that you want?
That depends on the higher level API that uses this. So this is just the design of the low level API where you can easily handle the data, and then how you handle the data we can decide later on. Because these are just sub VIs so we don't have to deal with the low level data, the array and the other array, the 2D array and the 1D array. And you can make VI to get the child, set the child, get the data, get the data size, replace data, add data, and delete the data. So basic array operations. So using the add, we can simply insert the 1D array twice, and you get 2 sections. And over here, you just loop over the array and concatenate all the data. Right? It's not really difficult, but it's very convenient when you make a library to first do the low-level stuff, and then you have Lego blocks to build your higher-level stuff. So we can basically use these VIs like this to, for instance, get the names of the data or of the sections, and basically do everything we want with the data. So that takes care of the first layer in our API, the sections. But the content, this is what we want to do with the sections layer. But the content of the ini file, it's almost the same as the sections. So if we implement it, it would look like this. The only difference is that the get content and the set content is missing. But as this is a low-level API, we could choose to simply implement it anyway, and at a higher level decide not to call these functions. Right? They're there. But if you want to step into the content of a key, well, you're doing it wrong. It's a low-level API, so just don't do that. And this was the data that we stored. And we could extend it to fit everything. And then we can basically have a 2D array that fits both sections and keys. So in this case, I stored 2 sections with some random data as well. These parts are not used for the section because they don't have a value, just a name. So the middle and the value part are missing, and then when we have keys, for instance, we do have those values. Now, why would you want to do this? I can still access everything, of course. But because we now have one structure that fits both the sections and the content, I can actually get away with using one class. I can say, okay, I have a configuration object that's either a section or the content of a section. And if it's the section, it refers to itself. Not itself, but its own class, a different object of the class that contains the content of the class. Now, usually you cannot make a class refer to itself or a parent of itself, or a child of itself. So a parent class cannot contain a child because that would cause infinite recursion, or could cause infinite recursion at compile time. But a child class can contain a parent class. So what I actually do is, in the configuration object, I store a LabVIEW object. And because it's my own API, I know those LabVIEW objects are configuration objects. So the strings accessing the child actually goes like this. This is the array of children, and I can get one. And I know it's going to be a configuration object because I put it there. So I can cast it to a configuration object, and I get the child as a configuration object. And that saves me a lot of time, a lot of work, because I only have one configuration object, one class to deal with, and it does everything I want. Everybody clear on this? It's not completely essential that you understand it, but yeah.
I'm just curious, that composite object is the high-level configuration object, or is that the LabVIEW object? This composite object, and same, you have the LabVIEW object here, which is a super class of big object. I guess I'm just a little bit confused about what you're casting.
Okay. Do you know what the LabVIEW object is? That's so every class in LabVIEW inheritance from the LabVIEW
Oh,
object.
okay, so that's just the root class, okay.
Yeah. So it's the root class. Yeah.
Okay,
Yeah.
thank you.
So the configuration object contains an array of LabVIEW objects, and it.
So in the next slide, keep going there. What do you mean by composite object? Is that a real, is that an object that you've instantiated yourself?
I think
Or
it's
is
just
that
the
the
name.
LabVIEW object?
The composite object is basically this object, this class. The thing with programming classes in LabVIEW is that once you change the class name, the labels won't automatically change. So I usually don't do that. So I usually don't change the labels of input and output class names. So this configuration config object, that is this wire.
Okay. So config object and composite object are the same thing?
Yes.
Okay.
Yeah.
Thank you.
Yeah.
Yeah, it's object in and object out, essentially.
Yeah. Yeah.
Yeah.
So this is.
Is there a reason you're using the preserved runtime class versus just a two more specific class?
I think this one could be a little bit cheaper. I'm not sure actually if there's a main difference.
What was the question?
The question was why I used the preserved runtime and not two more specific. I think there shouldn't be too much difference.
But I was just curious if there's a reason.
Of course, I put an enum in the API to access the value types I want. That's a minor thing. So now I can use that API for more advanced things. I can create a key. This is very low level still, but it's a low level API that we're going to use in a higher level API. And I can use it to create a key and add it to the section. This is the same code that I had earlier, except with empty values. And well, this function basically loops over them and steps into them and loops over it. And you get your ini file as desired.
Why are all the spaces there? Is it just for illustration purposes, or do they have meaning?
These empty values?
Yes.
No, this area, array, this is the values in that array. It's pre, name, middle, value, post, and type. Just so it fits everything. So a key has a pre and a name and a middle and a value and a post, but a section only has a pre and a name and a post. So
Does that mean that when you're building the type, you have to, in the next slide, it's important that you know where you put blanks and where you
yes,
put
Yes, but only at the level of the low-level API. So this is still no user of the library will see this.
I see.
It's
see.
just
Okay.
the VIs that I use at another abstraction layer.
Okay.
Also, there are one or two. This is one or two larger than I show here because there are few hidden features that I'm not describing in this presentation. So here I store them, and here I can do the same for reading the values. I can get the name from the two objects, or child, and get the name from the child. It's not. This is why we build the API. It's very basic functionality, explained in a very difficult presentation. So here's how we're going to use it later on. This is our configuration object that we made. It's recursive, and this is going to be the user API. I think I'm going to skip some content later on, but the higher level API, these are all the maps that I made in the higher level API. Open and close contains the from string, from file, to string, to file. This one is to get from one configuration to the other. It's not important, and the close is also not important because we work by wire for now. The from string to string is very important for me because when you want to test and you want to do that with the NIWeek, you basically have to make a file and save it and then open it again just to get it. This is really silly. And then when you make changes and you want to see those changes in your ini file, you basically have to open the file again and then delete the file because you're done with it. So when you have functions to do that, it looks like this, and that's, well, to me this is an improvement from this to this. So these VIs would all use the low-level API. Once you make more complicated stuff, for instance, when you want to add some keys to an existing ini file, it gets more and more important to have the from string and not have to do it like this. Read-write value. We have a set key value that's polymorphic. All the instances of the polymorphic VI over here. At some point they will change to malleable VIs probably, but I'm now in 2013, so that doesn't work. Read is almost the same. These are functions that I want to use later on to get values from the registry and get variants from the registry. And this is the change that I made in the higher level API to cover the bug. So when you store double in an ICE library, it basically stores it as 0.6f. So it stores 6 decimals, even if you are storing nanoseconds or picoseconds. So you get 0, and that's really annoying. And this could happen at any time in your application, so you can make an application and finish it completely, and then the customer enters a value, and the customer calls you and say, I'm storing a value, and it doesn't read back. So what my application does, my library does, it actually tests how many digits it should use to be stored, so that it's always binary the same when it reads back. You can check it out in the library because it's going to be online. Didn't mention that, right? But this library is just open source and it will be available. So this is the way I use the VIs. The internals of these VIs I will go in some later on, but this is what I mean by allow control support. If you have an ini file with a section and 2 keys, and you have 2 labels on your front panel, I want the values of the ini file automatically to appear on my front panel. And the other way around, when I have references to controls, I want them to appear in the ini file, be able to store them like this. So when I have 50 controls on my front panel, I can just use this VI and it will automatically appear in my ini file. How many people did this with their own code? Something like this? Only one? Okay. 2? Yeah.
Did you know that?
Yeah, OpenG does this, yeah.
So there's a second one instead.
Yeah, I could ask who hasn't done this before, and you also get 2 hands, so
yes.
I guess all the rest is just not raising hands. It's okay. I should have hyped everybody up like NI does.
You need strong music.
Yeah. So here's how variance works. You have your ini file and you have your keys in a cluster, or single values, scalar values also work. And you get a variant and you cast it and you have your data in your cluster. These are essential building blocks. Pretty sure OpenG VIs do this as well. Right? The other way around. So you have values and you store them in the ini file. This also works for classes, but only if the elements in the class follow this formatting. And I actually thought it was a bit weird to have a class load itself by another library, but then Dimitri said on the forum, single responsibility, so a class, it's okay if you let another class load a class, right? It's,
No.
Not? Okay.
Well, if you're talking about dependency injection, yes.
Yeah.
So I think what you're trying to point out is single responsibility principle says that a class should not load its own configuration or save. It should be delegated to some other class.
Yes. So you can do
Otherwise,
it.
it would be hard to change between an INI and a JSON, or between a file storage or a database. Because you need to touch all your 50, 60, 70 classes in the project.
Yeah, so it's okay to make something that loads classes
Yeah.
outside of the classes.
Yeah.
Exactly. That's what I got from the remark that you made. So yeah, you can wire a class here and it will be stored to file, and the class doesn't have to do anything about it. Except in my case, you have to make sure the labels are okay, because you need some way to tell which parameters need to be stored and which don't. There's some management functions: create, get the paths, delete some sections, move keys, stuff like that. These were by regular expressions, and if you don't understand the value of a regular expression, here's an example of an ICE. How to do it with an I. If you want to get the list of all the keys in sections with a number behind it, you have to make something like this, and it's no fun to make. So it's built in by my in my VIs. You can simply set a boolean to true, and the input will become a regular expression, and you get functionality automatically.
So where's your control? It's a section/d inside. Can you go back to the...
Okay. Over here. Over here, it's here.
Oh, okay, you have it as a... You don't have it as a control. That's what I was looking for. I was going to wait.
No, these are just snippets. So here it's over here it's a constant, and over here it's the same constant.
Okay, so it is a control.
It is a control of the get key names VI.
Yes. So the other slide should be a control. This.
Yeah, if you decide to reuse this, you make this a control, and you this a control, and then make a VI out of it. Yeah. This is basically the same for getting keys from a section. Over here I put the regular expression on the section. Over here it's on the key. You can also do your regular expressions on both. You have to be careful though, because the values are not automatically sorted alphabetically. But,
No, go back one. What happened to key equals value? Why isn't it in your list?
Searching by regular expression.
because it doesn't follow this regular expression. There's no /d. So you need to understand the regular expressions a bit, but key/d means somewhere in the string needs to
I'm
be...
sorry, you're right.
Yeah.
Sorry, I missed that.
Yeah. So if you don't write a Boolean, it will act basically, it has to be an exact match. There are some conversion VIs, and some of them are only used once, but I put them in VIs anyway because you make them dynamically stretch, and then you can inherit from it, and you can choose to change the way how strings are escaped or unescaped, or how a float converts to a string, for instance. Some tools. Don't think. What's important is the probe. That's very convenient. You can just put a probe on a configuration wire and you get to see your INI file. It's very, very nice. And for instance, here is what could be a VI to delete section 1. And this is just to illustrate that the low-level API is not quite what we want or what we need, because this tends to get more complex.
Can you go back? The other side? Or no? Yes, that one. So you get the index, and then...
Yeah, you're right. Yeah, this one should probably be wired over there.
Yes, yes.
Yeah. Yeah. It works because probably section 1 is the first section, so that's why it works.
Yes.
Yeah, yeah.
Yes.
Yeah, you're right. Good find. Yeah. I'm glad this is not in my library. This is an example to show that this is not what we want. Yeah.
I thought I was asleep.
Yeah, no. No, very. Over here you have the same problem, right? You want to wire the I.
You need the index.
Yeah. And then you have another problem because once you delete one, you have to subtract one from the index. But the point is that to do a simple delete, you still get very complicated code. You get code like this, and this is without a regular expression. So you make VIs like this to delete a VI or delete a key. You might make the same VI with a different VI here to change the key. And all the stuff that you want to do on a key is basically the same, except this VI. And that's a problem, because you end up with copies of the code, almost identical code, and then you decide, okay, I want to introduce the regular expressions over here and over here, and you have to go over that code and change it all again. So that's not what we want. And this is a solution, and it's not easy to explain, but what you can do is make a sub-VI from this, put it in a method. In this case, I call it the insert query. And then the values that we want to insert, we put in init. Oh, first we have an execute, and then the values that we want to execute, we put in init. So this gives us an opportunity later on.
So you have a separate class for your insert?
Yes, I'm making a class to perform the insert. Yes.
Any advantage? I'm just curious.
I'll show you.
Okay.
I'll show you. Because what we are going to do, we're going to add more functions beside the insert. So over here we just execute to have some inputs and outputs that we are going to need for all the functions. And we're going to put it in a parent class. And now we have the insert query in a configuration query. And we can do the same for multiple inserts. Over here we have an array of inserts, and we can put it in a for loop and put this code in a class and call it Composite query. Will look like this. There's a lot going on here. So over here we have a composite query, and over here we have a configuration query. That's because if I insert 0 queries, I return the base class. All details, not that important. This is the UML when we're done. And we can do this for all kinds of functions. For instance, here we have a conditional query. If one query returns true or false, you execute one query or the other. And you make a VI from it, and again you put it in the same hierarchy. Here's a step in, so we're still working on the API, on the low-level API. Here's a query that steps into a child and then executes a query on the child. And we can do that same for all these functions.
Can you step back just a little bit, about 3 slides to, yes, Rob, yes. So what is the relationship between the siblings in this case? Since they do, so what is the difference between an insert and a composite query method? In other words?
The insert executes this one.
Okay.
And the other one executes an array of inserts.
Oh, okay.
Yeah.
Okay. That makes sense.
It's very difficult maybe to understand at first. It's also very difficult to explain in a presentation. It's actually not that difficult. If you get this, then you can do really fancy stuff with object orientation. Because once you have all these functions and all these executes of all these functions are very simple on their own. In practice it looks like this, so you get a lot of classes, a lot of tiny classes with tiny VIs in there. It looks like this. Composite has an array of queries, and you have some, this is not a complete list, but the trick is that now we can replace this with this. I'll step over this. I'll put them next to each other. This is our match query. It basically performs the loop over of each item. If there's a match, it steps in. If there's a match, we step in. Get the content, and then for each key, we check if there's a match, and if there's a match, we delete. It's very quiet now. Is this at all clear, or?
Yeah, the actual delete is in the execute at the top, right?
No. Over here, you're just calling the inits of all these functions,
Right.
and you're building a structure of queries.
Yes.
And then for this query you say execute, and this one starts executing. So it executes this object's execute, and once it finds a match, it steps into this, and it starts performing the execute of this object. So all the work is done here. Over here you just build a hierarchy of objects.
Right. Yes, so that all the work's done in the top of, yeah.
It is a functor, basically, but a very complex one. A functor where each functor contains other functors. So you get a tree of objects, and it's executed here. And now we can replace this for this. So that's, to me, this is a win, right? You don't have all these VIs with very similar, complex, LabVIEW primitives, but you have something like this. So what I did, I even made a sub VI from this because I use it for everything that acts on a key. So this is something that we can do.
Question.
Yeah.
On that one, Is there a reason that you would start with the key instead of the section first?
It's not starting with the key, because the first thing that's executed is this one, and that's the section.
Okay, so so even though it's wired in one direction, it's executed
Yeah.
and the
No,
other.
no, no, no. Why is that the first one that's executed? Because it can't execute until match query init and step in query init because of data flow.
They don't execute. This doesn't execute. This is the init.
He's talking about building up a structure, like a hierarchical structure, and then in the execute, he's operating on the hierarchical structure. So even though he packs the structure from the bottom up, it executes from the top down.
Oh, I see what you mean.
Yeah, that's why I asked.
So he's building the structure
Yes,
and then execute operates on the structure.
you got it.
That's fair.
And this is a
Which-
tree-like structure we can kind of
Yeah.
build here? Okay.
We're just getting confused over the word execute.
This doesn't execute. These VIs are basically just saying, okay, put this in a private data of this object.
Right. It's building a structure.
Yes.
This one is also put in
Building
a
the
private
data
data.
that
execution.
execute.
Real quick, can you remind me what the step-in query is?
The step-in steps in from a section, and if it matches, it steps in the content of the section. Yeah, and then basically you do the same. Those executes functions needs to be the entrant, because otherwise you have a match query, and over here you have a match query. So it calls itself, and then you get a runtime error that you're trying to recurse over the same VI. So,
And the initial delete query was just to zero it out, to start off with.
what delete does is it deletes the current index, so the execute actually gets an index from its caller. So when a key matches, the match says, okay, this is the index, and the execute of the index gets the execute of the delete gets the index from the match, and it will delete.
Okay.
It's really not that hard. If you look in the code, it's very simple code, but it's if you don't ever make this kind of stuff, I think it can be difficult at first, but it's just a concept, and once you get the concept, you can make formula parsers and tree structures and all kinds of fancy stuff. It's a really neat trick to know. This is just a show off of the feature. I made a search and replace string query, and by calling it in this VI, I can basically replace all the commas in the keys with points, just by making this VI. With that expression again. So yeah, it doesn't even matter if there's anything before or after the numbers. Yes.
The query API is exposed at the top level, or is it all kind of internal to the registry class?
You mean if it's accessible to users?
Yeah, like is this just an example, or is like that execute key query, is that a public?
This is a public VI. Yeah. And this is a hierarchy of classes, and you can make your own, or inherit from it, or override it. Yeah. As long as API is free, and I'm giving it away for free, and it's open, so why would you make it private? This is a little bit easier maybe, but 10 minutes. I think I'll just skip over this because this is too difficult, probably, in 10 minutes. I'll go to this, because this is why I choose to make a class or why I choose to program object-oriented in the first place. There are a lot of things to override, and that means that if you want to use ini files but you don't like how I read it from or to file, you could even decide you want to open it from a database or whatever, or you want to encrypt it first. You can simply make a child from my library and say, okay, I override the toString function, and the entire library can stay the same. And just by using your objects instead of the parent objects, you get that functionality. And you can do that for all the conversion things. I'll show a few examples. This example doesn't make much sense because I didn't explain this, because I skipped it, because I'm running out of time. Getting a control value from the registry by its reference, it uses a helper class, if you want, if you will, to do that. So all the control handling, it's done in here. That means it's a class that configuration class uses. And I override one VI in that class, and all of a sudden I can decide to not use the labels, but instead use the description of controls to get the value. This is something my colleague wants. He said, I never use the labels, so I want to use my own labels and then use the description to get keys from an ini file, okay, if you want that. It's just one VI, a class and a VI, and you get this functionality. Here's another one, and this one is on the high-level API that we talking about. You make a child from the ini file, and you override the get key value and a VI to get the trill. It's not that complicated. Here you get the trill, and when you set the key value, you add it to the array, and then your code automatically keeps a log of all the ini files that you save. So in practice, you should also do this for delete value and maybe some 2 or 3 other functions. But then you have a full order trill. And the neat thing with object-oriented is that the entire code that you have that uses the ini file, you don't have to change. It can stay the same. And if you made the override correctly, you don't even have to test again, or you can logically assume that it will still work. Another override. Sometimes you don't want the default values from hard-coded. You want to specify them in ini file or outside your application. So the only function that you need to change is the get key value, because that is the one that returns the default if it doesn't exist. Looks like this. In the init you say, okay, I want a file to specify the defaults. And when the parent fills in finding the default, I get it from an ini file, this ini file. And all of a sudden you say, this is my ini file, I want to read key 1, it exists, so it returns value. Key 2, it doesn't exist, and it doesn't return new value, instead it returns default 2. Specified in my ini file. Key 3 is not in my ini file, so it still returns the old default value. Some features that are not covered, I'm not covering it now. What needs to be done, documentation of course, manuals, examples, unit testing, presentation explaining it all, very good. But it's difficult stuff. Explaining code in a PowerPoint is hard. There's a class that does the encoding, so for some reason I saw that I needed to convert UTF to UTF-8, but LabVIEW uses multi-byte single character encoding. Once I have that, you can put Chinese in your ini file and get those Chinese characters on your LabVIEW if your code page is correct. So that's something I want to have. The library needs a place to live. For now, it will be on our website. If you want it, give me a card. I can send it. Send me an email and I send it to you. I hope eventually it will be on Tools Network, but it's a lot of work to make menus and descriptions and get it out there. Are there any questions? No? Nobody? Good.
Yeah. So I wonder why do you use this approach with explicitly programming stuff instead of like the easy XML from JKI? They have a version for INI, or the read-write anything from MGI. You give them it a cluster, it generates the file for you, and then you read this file, it returns the cluster of the type.
But I think in my application, what the user wanted was to not only read the file from a string, but also to specify what the source of that data needed to be.
Okay, so those two libraries did not satisfy your requirements.
Yes.
That's why you did it.
Yes. Yeah.
Okay.
And not only that, what I wanted was a library that does the basics, but if I want it to be more complex, I can simply inherit from it and put the complexity in the child class. So that's basically the reason why I want libraries like this to be object-oriented. I'm not sure if the JKI APIs are object-oriented, might as well be.
I don't remember. The MGI ones are not.
I think we have a few minutes. I might be able to show the application that I use it in. Okay. More questions? No? I think we're out of time, so thank you very much.